Trac's energy and carbon footprint application collects data from meters and sensors. An admin interface, secured by encryption and multi-factor authentication, allows admin access to near real-time sensor readings. Energy consumption readings are also secured by tokens, encrypted credentials, and zero-trust network cybersecurity. Carbon emissions factors and costs are applied, as well as other sensor metadata, before the readings are stored in an encrypted NoSQL database, where it is aggregated hourly and daily. The data is aggregated by type of sensor, as well as by facility building, and by geolocation, able to be viewed on a 3D map. Automatic updates are read by the analytics software, so that admin dashboards show the most recent calculated energy consumption and cost figures. The dashboards can be enriched with additional information, such as building features, for example square meters of floor space, construction materials. Energy consumption patterns, such as peak and off-peak time of use, can be applied to the data. Out of the box, Trac provides customizable dashboards of energy consumption, collected from facility meters and sensors, networked over a secure data pipeline to analytics software where data can be fully controlled by the organization that owns it. Highly secure, and very customizable, with the capability for access to data to be tracked, monitored, and logged, with configurable alerts and alarms applied to the data and the security of the data. Configuration of admin access is in the hands of the organization, so that only authorized personnel can see credentials and any other private data. Account data is fully owned and managed, after Trac's stakeholder engagement exercise provides the knowledge transfer to do so. How does Trac organize the data it collects? It is built on a customizable energy and carbon emissions reporting model that is fully integrated with enterprise resource planning data, such as asset management and vehicle fleet management. The model includes business process automation and extends to technical design and development. Building data can be viewed by corporate grouping and applies configurable tariffs to each facility to monitor consumption and cost. Data can be collected from existing sources to build a holistic view of energy efficiency. Application of technology persistence factors provides the anticipated lifetime of an energy efficiency technology and can be used to calculate lifetime savings. The persistence factors are used in the calculation of cost to save a ton of CO2 over the lifetime of an application. This means that comparisons can be made between different technology projects to work out the most effective way to reduce costs and emissions in the shortest possible time period. This is really useful information for decision makers, and when the data is collected by building and geolocation, projects can be targeted to where they will be most effective. In fact, one of the most cost-effective ways to reduce energy costs and carbon footprint is simply by auditing the way energy is used and applying common sense measures to energy management. For those organizations required to report on their global and annual national energy use and greenhouse gas emissions, the Trac model provides the framework for standard reporting categories, making it easy to apply conversion factors for greenhouse emissions reporting. These conversion factors apply to all energy consumption activities, such as electricity, gas, water, vehicle fuel, waste disposal into the equivalent carbon emissions. Countries are required to report annually to the United Nations, and as emissions tracking is becoming increasingly accurate, Scope 1, 2 and 3 carbon accounting requirements are likely to become more stringent over the next few years. Organization grouping is customizable so that reports are meaningful to internal corporate structure. The model is the basis for Trac's energy and carbon emissions database, and as all elements are connected, this provides a very convenient way to understand energy consumption and carbon footprint for the whole organization, as well as for each business unit and facility building. The energy and carbon footprint model provides a comprehensive data collection structure, and it is not only a model, it is instantiated as a SQL database. Trac has a worked example in Postgres. This enables extended and comprehensive reporting, based on pre-existing sample analytics dashboards, making it very simple for data scientists to use existing analysis and build new reports without having to start from scratch. Trac is currently building a machine learning AI model to apply to detailed, granular, time series energy consumption readings to detect hidden patterns and potential anomalies. The database is available to be used and customized to meet sustainability reporting challenges. It provides significant time and cost savings, compared with finding the skills, knowledge and time to build an entire energy and carbon emissions reporting data lake. Yet, unlike some of the sustainability reporting tools, it is a sophisticated data engineering, not limited in its coverage, and is designed to readily integrate with existing energy data collections, and enterprise asset management databases. In summary, the Trac Car energy and carbon footprint application is secure by design, incorporating best practice access, authentication and authorization, supported by field-level data encryption for sensitive data, meaning that device configuration, admin access, and reporting is fully protected. Organizations can deploy the application to their own accounts, meaning that the data access can be completely controlled to meet internal security requirements. The application integrates with data collected by best-of-breed energy sensor supplier Hildebrand. Trac Car securely connects to data collected over Hildebrand's highly secure DCC network capability. Their sensors provide cyber-secure communications over protocols supporting narrowband radio frequency networks, as well as devices to collect data over conventional wireless and wired networks. And to access sensor readings, Trac Car's data collection, storage and access has been designed with defense in-depth criteria at the forefront. We offer stakeholder engagement with business and technical people, to transfer knowledge and skills, as well as providing guidance to deploy the application in a way that meets with private security requirements.